Alright, so in this video we are going to be going over how to test your code. So up until now, probably a lot of what you've done to check to see if the code you're writing is working as expected or as intended is you've been doing something called visual testing. And so here's a little example of visual testing. This is a code from when we first introduced the stack container in C++, and one of the implementations, or one of the behaviors that we wanted to program in was the ability to print out the stack. And printing out the stack allows us to see what is stored in the stack. And so it's a form of something called visual testing, which is a great way to test your code and something we all do all the time, but it requires a lot of manual labor, and if it's something that you're doing just as like a spot check here and there, it works great. But if you're trying to kind of thoroughly test to see if some functionality is working, it's really cumbersome. It takes a lot of effort. It also relies on human checking, which is not very repeatable and also not super reliable. So what we'd really like to do with our testing is have tests that are repeatable, automated. They're really easy to determine whether something pass or fails, so it's not something you have to visually check. It's not something that you have to calculate after the fact. It's something that's determined as it's run, like it says, passed, failed. So one example is something that you've been using for your whole academic career, which is all the autograders. So all the autograders that we use are test cases that the instructors are writing, or like in Zybooks, some of those are built into the textbook. And these are no different. They're exactly the same as the test cases you're going to be writing. And it's not just an autograder, in that way. It is actually a whole framework of how to write code. The test cases need to be small enough that we can see, step by step, what about your code is right and what about your code is not right, so that you can get partial credit, and have feedback on what portion of your code is still not functioning, right? So, one of the bad habits that lots of us get into the habit of doing is relying on autograders, because it's great when you know exactly what your code should do based off of this big system, and you can just blindly test to that. But that's not really very realistic with code writing. When you go out and write code in real systems, there is going to be test cases to test against if you're changing code that's already functioning, and that will be great. But if you're developing new parts of the code, which I really hope you are doing, otherwise it'd be pretty boring if you're just maintaining code your whole career, then you need to have something to test against. And so it's going to be, definitely something you're going to do. And so you don't really write code without writing test code, right? So they come hand in hand. So we wanted to make sure that in this class that you saw that and you started working towards that. So we're going to talk in the next, in this video and the next couple of videos, how that's done. So this is an example of something called a unit test. All of the code that I'm going to be showing you in this next couple of videos and these next couple of slides, it's linked so you can have access to it. So I'm going to go over this code next time. But basically, it's really similar to probably what you are familiar with already with printing out your code or testing that it has the right values or whatever. There's just some syntax. So this is part of a framework called part of the Google test framework, which we'll talk about in the next video. But the basic idea is that you're writing these little functions, and each function is testing a different aspect of a particular class. For this example, I'm just testing the stack implementation with C++, so we're pretty sure that it's pretty good. But it's like a good way to practice writing the test cases, and you don't have to bother with understanding like another API that you have to look at in order to see test cases. This first version, we're just going to use something that you already know how to use, which is the stack. So here is 3 test cases, and we'll go over them in the next video, but this is sort of what unit testing looks like. It's like standard in industry to do unit test casing. What? It's standard to do unit testing in industry, and in any software development at all, whatever it's for. And so the idea of it is that you really break the functionality of your code into units. It's really easy to do with classes because you test each member function, but you want to break it up into testable pieces. And I think testable is probably not a word, but you get what I'm saying. And you have a lot of tests. So project 2, I think it had probably more tests than that, because each test case has more than one test inside of it. But in some of the project test cases, there's like especially the ones where we're testing classes, one test case. So maybe there's 30 test cases in project 3. One test case might have 100 assertions in it, like 100 things that it's testing. So when you test, there's a lot of things that you're testing. So a lot of it isn't like individual assertions. It's like in a loop, and the loop is running 100 times, so you get 100, but it's like one line of test code, right? But lots and lots of testing. And the thing that we're going to learn now is looking at some frameworks that allow you to test. So you we'll get a sense of how you don't have to write all of this implementation yourself. So you don't have to write a bunch of functions and check all these comparisons and then call those and count them up and print them out. That's already kind of done for you in these different frameworks. And depending on what system you're using, so obviously it's going to be set up for you on our system, but if you're using a Mac and you're using Xcode, or you're using a PC and you're using Visual Studio, you can like integrate the tests into those IDEs. Some of them work cleaner than others, but they look a little bit different depending on the IDE that you're working on, and so you'll kind of see some of that. So when you are designing code and software, you have to keep tests in mind. You write code and you write tests alongside it. They're maintained together. And if you look at kind of like the day in a life of a software engineer, they're writing code, they're writing tests, they're checking in their code, they're getting their code reviewed and checked and approved before it goes into the system. And there's a lot to it, right? So a really small part of writing software is writing the actual code itself. Probably a much bigger part of writing software is testing it and writing the test cases. So how many test cases are enough? This is probably the most uncomfortable part about testing, is that it's never enough, and unit testing doesn't guarantee that your code is even correct. This is a really great quote by Dijkstra. Testing shows the presence of bugs, not their absence. So there's no amount of testing that you can really guarantee that your code is working, is functioning under all edge cases, has no bugs, etc. That requires you going into theory land of CS, and that you can go into the direction of formally proving these types of things, working on better programming languages, etc. But it's sort of like an uncomfortable reality of software development, is that you're kind of always in this state of not having enough tests. Like you just never can have enough. So that's it for this introduction to testing.